All right, let's take a peek at question 821. Mr. Webb has only one more starting position available on his basketball team, but 2 students have tried out for it. He wants to choose the student who is likely to score the most points. The 2 students from whom he can choose are described below. So A says, in her most recent games, Jana scored the following points, while Alejandra scored the following points. Which girl has the higher average or mean number of points? All right, so for this, what I did was I put their points in order from least to greatest. Now, you don't have to do that for the mean, but it is going to make it easier. You will have to do it at some point later on in the problem. So, to find the mean, of course, what we need to do is add up all of the scores and divide by how many there are. So, Jana had a total of 234, and there were 16 scores total for her. So, if we do 234 divided by 16, we end up getting a mean of 14.625. And then for Alejandra, when we add up all of her scores, we get 117. And there were 8 scores total. So when we do that, interestingly enough, we also get 14.625 to the decimal. So we're going to say for part A that the girls have the same mean. All right, on to part B. It says, which student do you think Mr. Webb should select and why? Use parallel box plots, which is 2 box plots on the same number line, to support your explanation. So if we're doing box plots, that means we need to find the median, first and third quartiles of each girl's data. So if we're looking at Jana's, when we find the median, let's see. So I always start by going from either end and working towards the center. All right, so it looks like it's between 9 and 9. So the average of 9 and 9 is going to be 9. So Jane is going to have a median of 9. And the first quartile is going to be the center of this lower end of the median. So let's see. Looks like it's between 7 and 7, so the average there is going to be 7. And then an upper or a third quartile. Again, that's going to be the median of the upper half of the data. So it looks like it's between 11 and 11 here, so that average is going to be 11. All right, now we're going to do the same for Alejandra. Let's find the median first. All right, median is between 15 and 15, so Alejandra has a median of 15. First quartile is going to be the median of the lower end of the data, and it's going to be 13. Because it's between 13 and 13, and if we average those two, it's of course going to be 13. Now third quartile, that's the median of the upper end of the data, and it's between 17 and 17. So if we average those two numbers, it's going to stay 17. All right, so now let's go ahead and make that box plot. Looks like I didn't leave room for that, but that's okay. now it said to do it on the same scale. So the girls' lowest score in points was 6, and the highest was Jana with 55. So let's go from 0 to 60. That would be an appropriate amount. So we'll go 0, and we can go by tens. That's fine. All right, so I have my number line that goes from 0 to 60. And I just want to go ahead now and put box plots for each girl on here. So I'm going to do Jana's in purple, Alejandra's in orange. Now Jana, her lowest number of points was 6. Her highest was 55. So this is going to range from 6 to 55. So 6 is going to go all the way up to 55, which is going to be halfway between 50 and 60. So right there. Now for our box plot, we need to plot the median, first quartile, third quartile. So our median was 9, so it's going to be right below 10. The first quartile was 7. So it's going to be right about here. And then, okay, and then our third quartile for Jana was 11. So that's going to be right after, just right above 10. So there is Jana's. So this is for Jana. And then Alejandra's will do an orange. So Alejandra's lowest score in points was a 9. The highest was 18. So hers is going to range, it's going to go right below 10, so 9, all the way up to her highest score was an 18. So it's going to be not quite to 20. All right, now we need to plot her median, first quartile, third quartile. So the median was 15. So it's going to be right in between 10 and 20. First quartile was 13. So it's going to be right about here. And then the third quartile is 17, which is going to be just above 15. Right about there. All right, now we can connect those to make our box. And this one was for Alejandra. All right, so we have our box plots here. For part B, let's see, so told us to use parallel box plots, which we did, same number line, yes, to support our explanation. So we need to say which student do you think Mr. Webb should select and why. All right, so we have our box plots, we have our mean, quartiles, all of that. So now we want to explain who is a better choice and why. So if we look at our medians, if we look at our medians, not only here, but in our box plots, we could see that our median, I'm going to trace over in green for both girls. Oops, I didn't want a highlighter. I wanted just a pen in green. So Alejandra's is here. Jana's mean is here. So we could say then that Alejandra scores more points. So Alejandra scores more points according to the mean, or I'm sorry, according to the median. The girls had the same mean, which is what we did in part A, but according to the median. Okay, so now we'll go ahead and move on to part C. Part C says, why was the mean not a good measure of Jana's typical performance? So, if we look at Jana's performance, if we take a look at this box plot here and everything that's in Jana's box plot, we can see that we have this huge line that is off to the right. So, Jana's data is not symmetric. And then even if we look at her scores in the list of her, well, it's kind of hard to see now, but because they're crossed out, but she had a 46 and a 55, and those are a lot higher than her next highest, which was 19. So we could say that those scores are outliers. So let's go ahead and put that into words now. So, again, Jana's data is not symmetric. She has outliers, so there are a few outliers. And those outliers, again, were 46 and 55. That's all we need for part C. So let's go ahead and take a look at part D now. D says to calculate the interquartile range measure, or to measure the variability of each girl's performance. So let's take a look at Jana's first. So again, to find the IQR, or the interquartile range, we take the third quartile and subtract the first. So Jana's third was 11. Her first was 7. So Jana's interquartile range, we're going to do 11 minus 7, which is 4. And then for Alejandra, her third or upper quartile was 17. Her first or lower quartile was 13. So we're going to do 17 minus 13, which gives Alejandra a interquartile range of 4. So really when it comes down to interquartile range, the girls' scores both vary by an IQR of 4. So E, let's have a look at that part. It says, who had the higher median and by how many points? How large is the difference between the medians measured by how many interquartile ranges would fit into it? So, let's see. Jana had her median, I'm going to write it over here. Jana's median was 9. Alejandra's was 15. So we will say Alejandra's I think I meant to say median. So her median, it was 6 points more than Jana's, All right, and then they wanted to say who, let's see exactly what it said now. So how large is the difference between medians if we are measuring by how many interquartile ranges would fit into it? So what this means is we're going to take a look at both girls' medians. Now Jana had a median of 9. And remember our interquartile range is 4 for each of the girls. So what we want to do is when we are looking at how many interquartile ranges would fit into their median, what that means is take that median and divide by the interquartile range, which is 4. So if we do for Jana, 9 divided by 4, that gives us 2.25. And then Alejandra, if we do 15 divided by 4, that gives us 3.75. So Alejandra did better. If we take the difference between these two, Alejandra did better by 1.5 interquartile ranges. So we're going to say Alejandra did better by 1.5 interquartile ranges. All right, and then that is all for problem 821.